Hi guys, this video is going to show you how to work a two-trait problem without making a great big 16 square Punnett square. 16 square Punnett squares they take a long time to make, and it's really easy to make mistakes. So you can actually shorten your work by just making two separate 4 square Punnett squares, and this is going to show you how that works. Alright, so the example problem that we're going to work is similar to the problem that we worked on the practice test or the pre-test that you took. In peas, purple flowers are dominant to white, tall plants are dominant to short, and we're going to cross two plants that are heterozygous for both traits. We're going to be able to answer these questions really easily rather than making that two-trait 16 square Punnett square. All right, step one is to create a key. So we're going to go back to these questions in a second. So to create a key, the key is just showing what your letters represent, how you're representing each trait. So it's easier if I just show you. We're going to start with the flower color. Purple is dominant to white, so I'm going to use the letter P for purple. It doesn't matter what letter you use, this is just kind of standard. Since P is dominant, or purple is dominant over white, I'm going to represent white with a little p. Never write two different letters. In other words, don't represent white with a different letter. You're using the lowercase letter because the uppercase letter, purple, is dominant over white. All right, and then it says that tall plants are dominant to short. The key for that, tall is dominant, so little t, short, is recessive. That's what I mean by making a key. What do your letters mean? Now, to write out the parent cross, you're just going to go back up to the problem and show the genotypes of the two parents. So the way that you make a parent cross is like this. The two plants that we're looking at are heterozygous for both traits. Heterozygous means you have a big and little letter in each one. Each one has both alleles, both different alleles present. So heterozygous for color would be big P, little p. Heterozygous for height would be big T, little t. That's one parent. And it says that both of the plants are heterozygous for both traits. So here's your other parent. They're both the same. All right, now, step 3 says to use one Punnett square for color and one Punnett square for height. So let's take color first. Here's my colors. This is the color for one parent. This is the color for the other parent. So I'm going to use this Punnett square just for the P's. We'll save the T's for later. All right, this parent, I'm going to put the alleles here, big P, little p. This parent, I'm going to put those alleles here, big P, little p. Remember to make your big P's really different looking than your little p's so it doesn't get confusing. When I combine those together, I carry this one down and this one over. I get big P here. This one I get big P, little p. You always write the big letter first. Here I have a big P, little p, and then here I have two little p's. All right, now for height, I'm going to do the height Punnett square here. So here's my height. Big T, little t, big T, little t. I got that here. This parent, big T, little t. This parent, big T, little t. And then I'm going to put them together in my Punnett square to get my possible offspring. All right, so what you can see is that 3 out of 4 are purple. And 1 out of 4 are white. So my offspring, the probability that I get from these parents for purple is 3/4 purple, 1/4 white. If I go over here to height, again, 3/4 are that dominant trait, which is tall, and 1/4, just this one here, is short. The last step, once you've done that, and it's much quicker to make 2 separate Punnett squares, the next step is to figure out the chances of each event occurring separately and then multiply them together. For example, if you want to know what the chances are of getting both tall and purple, you figure out the chances of getting tall and multiply it with the chances of getting purple. So let's go back up here to the problems that we're going to solve. Number 1, what's the probability, and we're going to write that as a fraction, that the offspring will be purple and short? So first let's start out with purple. If I go down here, there's a 3 and 4 chance, or a 3/4 chance, that the plants will be purple. So write 3/4. Then for height, I want to know what the chances are of it being short. So if I go over here, 1/4 or short. So let's write that 1/4 up here. And then according to my directions down here, you're going to multiply the chances of each separate to see what they are as far as occurring together. So I'm simply going to multiply those two. 3/4 times 1/4 is 3/16. So there's a 3 in 16 chance that I will get purple and short. Had you filled out a large Punnett square with 16 squares, 3 of those 16 would have been purple and short. The next one, what's the probability the offspring will be white and tall? So if I go down here to white, there's a 1/4 chance of being white, and there's a 3/4 chance of being tall. So again, that's going to be 3/16. Finally, what's the probability that the offspring will have the same genotype as the parents? Notice I put genotype in caps so that you would pay attention to it. Genotype is the letter combination. So I want to know the chances of getting offspring that have this combination, big P, big T, little t. So go to our Punnett square. Let's look at the P's first. Notice you have 1, 2 that are big P, little p. So that's 2 out of 4, which is half. Over here for the height, what are the chances of getting big T, little t? 1, 2 out of 4, which is half. So that's 1/4. 1/4 of your offspring would look like the parents in terms of the genotype. All right, I hope that helps. After this, you're going to do the Kahoot, which is going to review stuff that we've done so far, and there is a problem like this on there.